Okay, so the first thing that we're going to need to do in order to get started with the BeMicro Max 10 is we're going to need to download the Quartus software package, and this can be found on the Altera website. I've already gone to the download center and I've actually logged into my own account. I will put this link in the description of the video so you can easily get to this page. And then you're also going to need to create an account. The only thing that you're going to need to do is give them a valid email address and a password, and you're good to go. So once you've created an account, we can scroll down to the different versions of their software. Since we're going to be programming on the BeMicro Max 10, we can select by device. So we can go to the Max series here and Max 10 there, and what we're going to do is use the free version, and that is the web edition there. So let's do the 15th version, which is one of their latest versions. Okay, so this is the download page. If we scroll down a little bit, you can see that we're going to get the Quartus 2 software. Perfect. We do need the model sim. Perfect. And then since we don't have any of these other devices, unless you do own them, we can just deselect them because we're not going to be using those devices. So we definitely want to make sure that we have the Max 10 FPGA device support, as well as these two selected. So let's download these files. Okay, so we just agree to that. So now it's actually starting the download for us. So I will actually pause the video and then come back to you guys when this is finished. Okay, so it looks like the download's almost done. Okay, so the software is finished downloading. All right, so we're gonna next here. Need to accept the agreement. Click next. Okay, so this is just the installation directory. I usually just keep it the same, the default. If you want to change it, you can change it. Feel free. So next. So it looks like we have a couple of options to choose here. Looking over it, we can just leave it all selected here. We don't really need this down there. So let's click next here and begin the install. Okay, so I will pause the video and get back to you guys when this is completed. Okay, so the installation is now complete. Okay, so we're going to be installing the device driver for the BeMicro now. Okay, ready to use. Okay, so Quartus 2 is launching right now. You can select that or deselect that. Doesn't matter. It's okay. Okay, so now that we have the Quartus 2 software installed, let's go over to the BeMicro and take a look at what we're going to be doing today. Okay, so this is the BeMicro Max 10 FPGA development board. Don't pay attention to any of these other wires. Those are from my junior project, and I just really didn't want to have to remove them for this tutorial. What we're concerned about today is just these LEDs here. There's 8 of them that we can choose from, and we're just going to be manipulating D1 here. So let's take a look at the Verilog code and get that little guy blinking. Okay, so now that we have Quartus 2 successfully installed, we're going to open that up and we're going to start a new project to work with our BeMicro Max 10. So we're going to select New Project Wizard here, or you can also go to File and click the New Project Wizard there. So the introduction, you can just click Next. The working directory for this project, I usually just save the project to my desktop. So, or if you have another folder that you want to keep all your projects in, that's fine as well. So if we just create a new folder real quick, and we'll just call this blink. All right. And then we'll select that folder. And the name of this project, we can just say LED blink. And we'll select next. Okay, so we're just going to leave the empty project here selected. We're not going to be using a project template. Next. Okay, so adding files. We don't have anything to add to our project. If you had been working on other modules from other projects and you wanted to include them, this is where you can add them. You can also add them in later. It just makes it easy if you want to grab all the modules that you need right here. Okay, so we'll just select next. We'll just leave all this blank because we're not adding anything. We're just starting from scratch. Okay, so this is one of those steps that you really need to get correct. There are many different Max 10 devices. As you can see, there's just this massive list. So what I recommend doing is actually taking a look at your BeMicro board itself and getting the actual name of the chip from the board. So I brought up a picture of a BeMicro board, and this name that you'll find is actually right here. So it's this number letter combination right here that is actually your device. So in my case, I have it's 10M0 8DA F484 C8 GES. Okay, so there is our device right there, and we just make sure that that's the correct device, and we select next. Okay, so now that we're at the EDA tool settings, the simulation should say Model Sim -Altera right there. Since we are not coding in VHDL, we need to change this to Verilog HDL. And we need to make sure that's correct because we're going to be coding in Verilog. The timing's fine, symbol, okay, that's all good. So just make sure that this says Model Sim Altera and then Verilog HDL here. And select next. Okay, so the summary is just tells you about your project, where it lives, what the project name is, top level design entity, and just the device in general that you're going to be programming. So everything checks out here, so let's finish. Okay, so now that we have successfully created a new project, we can go over to files, and what we need to do is we need to add a new file. So we're going to go up to File here and click New. All right, and then there's kind of a long list here, but you're going to have to find the Verilog HDL file right here. Select that and press OK. All right, so now it comes up with just like a blank document. What I usually do just right off the bat is I will save this just in case. So let's just save it, and you can go to Save As. For this module, we will call it, let's just call it Blink. Okay, and then just save. Okay, so now that it created a blink.v, that's perfect. So let's get to coding. So what I've done here is I have module blink, and I added in a CLK, which stands for clock, an LED, which is going to be the D1 from our BeMicro board. You really need to make sure that these names right here, so blink.v and blink, are exactly the same. Otherwise, you're going to get a weird error. So make sure that those are correct, at least spelled, capital, lowercase, stuff like that. Okay, so I know I'm going to be kind of going over the Verilog code pretty quickly. You might be lost, but that's okay. I recommend if you're not very familiar with Verilog to get a book on it, or you can actually take a college class on it. All right, so the clock is going to be an input, so we're going to type input and then CLK, and that declares this clock signal as an input to this module, and the LED is going to be an output. So we're going to say output LED. All right, and then what we need to make is a register. So we're going to have a register here, and let's just make it a 32-bit register. So it'll be 31 down to 0. Since we start at 0, it'll only be to 31 for a 32-bit register. And we'll just name this count. Okay, so now that we have our 32-bit count register, what we need to do is we need to have an assign statement. So we're going to type assign LED, and we're talking about this LED output here, and we're going to set that equal to count 25. So basically what this always block is saying is it's saying every time we have a positive edge on our clock coming into our module, we are going to do the stuff that's inside the begin and end statements. So what we want to do is we want to increase our register value by 1 every time we get a clock pulse. So what we're going to do is we're going to say count equals plus 1 B1. Okay, so basically what we're saying is every time we have a positive edge on our clock coming into this module, we're going to increase our 32-bit register counter by 1. So we're going to just be incrementing that register by 1 every single time we have a positive edge on our clock. Okay, so since this module is completed now, all we need to type in is end module. And just to make this tutorial simple, so you don't have to worry about coding this yourself, I will be putting this code in the description, so you can just copy and paste it into your blink.v file, and you're good to go. Okay, so now that the module is complete, we have end module here, we have the same file name here, so blink here, those are the same. Now we just need to check the code for errors. So to do that, we can just click on this little play button up top, and that'll check the code. Okay, so now that the code is complete, there's 0 errors. We need to do one of these critical steps, and if you don't do this critical step, the project won't work. So what we need to do is we need to go over to tasks, and once in the task menu, we're going to go to pin planner. So we're going to double click that, and that opens up the pin planner. And what we're really doing is we're just selecting pins, and we're correlating the pins on the FPGA to our code. So let's say we have the output LED here. What we need to do is we need to find the location inside the FPGA. So we have a clock and we have an LED. So what we need to do here is we need to go to the BeMicro Max 10 datasheet and look at where those locations are. So I already downloaded the BeMicro Max 10 datasheet, but what I'm going to do is I was going to put a link in the description to where you can download this datasheet for yourself and keep on hand. So if we go to the Max 10 datasheet, you'll find a lot of information, just everything you really need to know about the Max 10. But what we really need here is if we scroll down a bit to part 3 here, pin out information for the Max 10. So this is really what we need. You have an accelerometer, you have a digital to analog converter, temperature sensor, and all these have correlating pins. So what we need to do is we need to scroll through this, and we need to find the LED. Oh, there it is. Okay, so we need to find the LEDs here, and as I said before, we're going to be manipulating D1. So D1 is Max 10 pin, and that is M2. So let's go back to the pin planner, and let's type in M2 right here, M2. And if we type in M2, it auto-fills in pin, which is great. It just makes it easy. So if we click off of that, it just set the LED to pin M2. Okay, so now that we have the LED mapped, we need to get the clock input. And so let's go back to the BeMicro Max 10 datasheet, and let's scroll through this guy, and we will find the pin information for the clock. Okay, so clock inputs, so 3.6. System clock right there, and that's N14. So let's go back to the code. Type in, double click again, and then N14 right there. Perfect. Okay, so we have M2 and N14, and that's clock and LED. So perfect. So we can just X out of this, just close right out of that, and then we're going to go back to the code again. And let's go back up to the play button and press play again. Okay, so now that we have all the pins in the pin planner set, looks like we're all good to go. We have 0 errors. So if we scroll down in the tasks menu, you'll see program device right here. So what you need to do is you need to plug in your BeMicro Max 10. It's just USB cable, plug it right into the USB on the actual device, and power on your BeMicro. So once we do that, we have to go to program device, just double click there, and we need to go to hardware setup. Just make sure that you have this USB blaster selected. So if there's no USB blaster there, just go into that hardware setup, and select this USB blaster. Close out of that, and then the next step would be to add in the file that we've just coded. So to do that, you just go to add file there and go to the output files. So double click there, and what we're looking for is this SOF file. So let's click on that and open. And there you go. So we have the file selected, and we're going to program the BeMicro to this LED blink file that we just created. Okay, so to do that, we just have to click start, and 100% successful, perfect. And now let's take a look at the BeMicro itself. Okay, so now that we have the program uploaded to the FPGA, you can see that the LED is actually blinking there, which is perfect. I can turn off my desk light here, and it's blinking. So you have successfully completed the setup and LED blink tutorial for the BeMicro Max 10. I hope you enjoyed this tutorial, and I hope you take some time and learn Verilog and see all the cool things you can do with FPGAs.